Okay, so these are finding all solutions every single degree. So it's not going to be between just 0 and pi now. So 0 and 2 pi, it's not what we're doing now. We want all. And so the way we're going to be writing it is we're going to be adding to it some sort of pi k or 2 pi k or pi over 2k, but you're going to have to look at it and decide how it works. So let's just look at one. So we have here sine x is equal to the square root of 3 over 2. So we're going to look at this graphically first and then decide how it works. I'll explain everything. So here we go. So right now this line right here, this is our square root of 3 over 2. So this is when we have a y equals square root of 3 over 2. So now if we look at our sine function, as it goes through, whoop, there's one solution. So right there is a solution. So pi over 3 is a solution. That is when our sine equals. But we already knew that. If you look at our unit circle, our sine value is square root of 3 over 2 at pi over 3. So let's continue looking. So as it keeps going, there's another solution right there. So the intersection points are our solutions. So 2 pi over 3. See, there's the other one, 2 pi over 3. But what happens with a sine function is, remember, it's a sinusoidal wave. So it's just going to continue and continue. So there's another solution and another solution right here. So we have 1, 2, 3, 4 so far. And then it's even going to go in the other direction. It's going to go negative. So we now have some more solutions. That's a lot already, right? So just between negative 4 pi and 4 pi, we have a lot. And we actually have an infinite, and this sine wave will just continue forever and ever and ever. So we end up looking like this. 1, 2, 3, 4, 5, 6, 7, 8, and I would just keep continuing. So if I keep moving over, oh, there's more, and there's more, and more. I think you get the idea. It's just going to be, so look, we can go the other way too. So you just, lots and lots of solutions. So every single intersection point is a solution. So what we need to do is look at it logically and determine how do we find those. So we first start with just 0 and 2 pi. So between 0 and 2 pi, we know it's pi over 3 and 2 pi over 3. And we knew that from our unit circle. So it's positive square root of 3 over 2. This is our, let's go back and look at the equation. Our sine of x is equal to square root of 3 over 2 at pi over 3 and 2 pi over 3. And then these are negative, so they're not going to work. But you got to think about it. What happens is it's pi over 3, and then it's going to go around again 2 pi units away. So 2 pi units is how far we have all the way around, right? One rotation is 2 pi. So from pi over 3, and then 2 pi, and then 2 pi. And so that's what's going on here when we look at these graphs. So it hits these two values right there, and then 2 pi units away. So from here to here is 2 pi. That is 2 pi from here to here. And then from here to here is also 2 pi. So to get from here to here is 2 pi. And if you think about it, denominator is 3. So that would be 6 pi over 3 would be 2 pi. So 2 pi plus 6 pi is 8 pi over 3. So how you write it is very simple. We write the two answers. So we know it's 2 pi over 3. And then we write the other x here. And just to go back, remember you just look at the unit circle. Square root of 3 over 2 is pi over 3. And square root of 3 over 2 is 2 pi over 3. So let's write the pi over 3 first. And then the 2 pi over 3. And then we know it's just going to repeat 2 pi units away. And what the k represents here is an integer. And so we just say k is an integer. And so how that looks is this. We have x equals pi over 3. We'll look at just the first one. So if we have k equals 1, then we would have 2 pi times 1, which is just pi over 3 and 2 pi. So it's just one rotation. And if we said k equals 2, then we'd have 2 pi times 2, which is pi over 3 times 4 pi. And this is 2 rotations. So that that k equals 1 is just telling us how many times we're moving away from it. And so why we have it as an integer is then we can also do negatives. So this will then move backwards, see? And so from here to here, mirror image, that is a negative 2 pi. And from here to here, this is also, go away. From here to here, that's a negative 2 pi as well. And then that would be a negative 4 pi, and so on, negative 6 pi. And so all you have to do with these, you obviously don't have to graph them, is just look at your unit circle. If it says square root of 3 over 2 is pi, we know 2 pi later it's going to hit again. And if square root of 3 over 2 is an answer here, then we know it's going to be 2 pi over 3, and it's going to hit 2 pi again. So there we go. Let's try another one. Let's look at cosine x equals 1. So let me pull up the graph for cosine. So here is cosine of x equals negative 1. And so these are all of our solutions. And again, I can keep going forever and ever in each direction. So we just need to look from 0 to 2 pi. And so in that 0 to 2 pi, there is one solution. And if we look at our unit circle, cosine of x is the x-coordinate right there. So at pi, so we know one of our solutions for x would be pi. And so that's what we would normally write. But now we write plus, and then we put 2 pi k, because we know, looking at our unit circle, it's going to be negative 1. And then 2 pi away, it hits it again. And 2 pi away, it hits it again. Now, I don't need to see this. K is an integer. We're just writing it. It's not an integer. It's an integer. We're just writing it for right now. But all I want to do is see the pi plus 2 pi k. That's it. We already know that k is going to be our integer on each of these. All right, so that's pretty much it on each one. Okay, so what if you have a 2x now? So 2x makes it a little more complicated. So let's look at our graph. Let me unclick those. Go on the 2x. So you remember, if we put a 2 here, this makes our period occur twice as fast. So instead of going from 0 to 2 pi for one period, it'll be from 0 to pi. It happens twice as fast. So you can see there's our cosine, and then there's our cosine. So we get a solution here and here, but then it repeats. So within a 2 pi time, it's happened twice. So the way you do this is you just want to think about that 2x as our angle. And so we're just going to write 2x this time. So that was x. This is 2x. And you look at your unit circle, and we're trying to see, when does cosine of 2x equal a half? So cosine again is the x-coordinate. It equals a half at pi over 3. And then we also know it's going to equal a half at 5 pi over 3. So pi over 3 and 5 pi over 3. So you write that. Pi over 3. And then I'm going to put the 2x over here. 2x equals 5 pi over 3. But again, we know that at pi over 3, it's going to be a half. But it will repeat 2 pi later, right? And you may be saying, well, the graph repeated every pi. Well, don't worry. The math, the algebra, this is why algebra is so important, will take care of it. So we know that this is going to be repeating every 2 pi k. And then same with the 5 pi over 3. It'll repeat every 2 pi k, right? It's just going to be 5 pi over 3, and then 2 pi later, and then 2 pi later, and then 2 pi, and so on, so on, so on. So by solving it with algebra, we then take our 2x equals pi over 3 plus 2 pi k, and all you have to do is divide it by 2. If we divide that by 2, this already has a division line, so we put times 2, and then divide by 2. So we've divided each term by 2. So we end up with pi over 6 plus pi k as our answer. And so now when you look at our graph, look what it was. This one is pi over 6. And then that is pi later, 7 pi over 6, right? If you look at our unit circle, it's pi over 6, and then pi later is 7 pi over 6. So the algebra takes care of it for us. It's pi over 6, 2 pi over 6. Because normally it was pi over 3, but it's going to happen twice as quick. So it's half of the pi over 3, which is pi over 6. So all you have to do is look at the unit circle, treat it as what it is. So it's a half at pi over 3 plus 2 pi, and then we let the solving take care of it. So this would be the same idea. We know that our cosine will equal a half when 2x is equal to 5 pi over 3. Divide by 2, divide by 2, divide by 2. This is 5 pi over 6 plus pi k. And then if we check with our graph, see, it's 5 pi over 6 right here. This is our 5 pi over, let me get rid of this one so he's in a weird location. That's 5 pi over 6 right here, and then pi later, and then pi later, and then pi later. And it works the other way, negative pi more, and then a negative 3 pi, and so on. So all you have to do is say cosine of 2x equals a half, unit circle. Well, that's pi over 3. So I write pi over 3 plus 2 pi k because it repeats. Divide by 2, divide by 2, divide by 2, and there's our answer. And we also know cosine of 2x is equal to a half at 5 pi over 3 plus 2 pi k, and divide by 2, divide by 2, divide by 2. So if we have cosine of 3x equals 0, all you have to do is look at your unit circle. When is cosine equal to 0? At pi over 2 and 3 pi over 2. So we say that 3x is equal to pi over 2, and 3x is equal to 3 pi over 2. You're just looking at the cosines just like before. So 0, 3 pi over 2, 0, pi over 2. And then, so that's our first step, we say pi over 2 plus 2 pi k, because it's going to repeat. And then we say 3x equals 3 pi over 2 plus 2 pi k. And then we divide by 3. Oops, times 3. Divide by 3. And you get x equals pi over 6 plus 2 pi over 3 k. Divide by 3, divide by 3, divide by 3. X equals 3 pi over 6 plus 2 pi over 3k. It looks, well, we have a mistake here. This is really pi over 2. So we can now look at the graph, and you can see that we get right here pi over 6 and pi over 2. And then we now know by doing our little algebra that it's not 2 pi, but 2 pi over 3 away. So if you look at it, it's 2 pi over 3 away on each one. So let me unclick these right here so you can see it. So it's pi over 6, 2 pi over 3 away, 2 pi over 3 away, 2 pi over 3 away. So from pi over 2 to 3 pi over 2, and then 3 pi over 2 back to pi over 2, it's the same distance. So from here to here to here to here, it's always going to be the same difference. Even if you divide by 3, it's still exactly the same difference. So there is a shorter way to have written our answers. This is an alternate method. So if we say our 3x is equal to pi over 2, and then we look at our unit circle, from pi over 2 to 3 pi over 2, it's pi away. And from 3 pi over 2 to pi over 2, it's also pi away. So we could just say plus pi k. And then now, when we divide by 3, we get x equals pi over 6 plus pi over 3k. These are going to give you exactly the same answers as these two together. They're both correct. This is just a much more condensed form. And so you can see how it works. If we did pi over 6 and we start writing our answers, then when we say k equals 1, that would be pi over 3 away. Well, if you did pi over 6 plus pi over 3 times 1, this is pi over 2. That's that angle. And then it would just continue on that way. It would go through their unit circle doing pi over 3 away because it's 3 times as fast. Instead of pi, it's pi over 3. So it'd be pi, 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 but now it's pi over 3, pi over 3, pi over 3. It looks like this nice clean answer. So they're both correct. Whichever one you choose is correct. Just this one's a little better.